Now we're going to learn about how to find the volume of spheres. First of all, let's talk about a few basic facts that I think we've already talked about in class, but just to make sure that we all understand. The sphere has two parts to it. If you look at the formula down here for the volume of a sphere, there is V and there is R. Everything else is a number, so the 4/3 and the pi is just a number. So those are the only variables that we could have in this problem. And there is no h in the sphere because the height of a sphere is always going to be equal to its diameter. Or since we don't talk about diameter very often in these formulas, it only shows up in one of the circumference formulas. And we're always talking about r in all of these formulas. We would refer to d, or the diameter, as just 2r. Because that's what it's equal to. So then we would say that the height of a sphere is actually 2 times its radius. Here's the first example. Let's find the volume of a soccer ball that has a diameter of 9 inches. Well, again, I don't really care about the diameter because it's not in my formula. So let's divide that by 2 and figure out that r is equal to 4.5 inches. And that's the number that we're going to use for our formula. So I need to write the formula down. Then I need to substitute r into the formula. Then I need to calculate. You should try this calculation with your calculator just to make sure that you get the same answer and that you know how to raise things to the third power. So just the 4.5 is being raised to the third power, not pi, not the 4/3. I used the 3.14 approximation of pi to get this answer. There will be two kinds of problems that we'll see with spheres, since there are only two unknowns. There is not a column for height, like I mentioned at the beginning of the video lesson. Height on a sphere is just 2 times its radius. So the only things that we really could solve for in a sphere problem would be the volume of it, like I just did with the soccer ball problem, or knowing the volume, going backwards and figuring out what the radius should be. In this next example, we'll one with the 12.7 centimeter radius. Okay, so the formula that I need for this one, since it's finding the volume, is going to be V equals 4/3 pi times r cubed. And r in this problem is 12.7, and I need to cube that. Now that I've done the substitution and I calculate, I get approximately 8,575.9 cubic centimeters. You should also go through that calculation just to make sure, again, that you're doing your calculator steps correctly. For this next problem where I need to find the radius, I should rearrange my formula and set it up so that it says r equals. So let's do that down here at the bottom. So V is equal to 4/3 times pi times r to the third power. If I want it to eventually say r equals something, there's a terrible r, what I need to do is inverse operations to get r alone. So let's multiply by 3/4 to both sides. And that's going to reduce out the 4's and the 3's on the right. Then I should also be dividing by pi. And that reduces out the pi's on the right. And then I need to do the third root, or the cube root, of both sides. So the cube root of 3/4 times v over pi, which can be combined to make the cube root of 3v over 4 pi. So if I just plug my numbers in, here's v, then I can figure this out. So here I've done the substitution. I got my 3 times 50, or times the volume, all divided by 4 pi, and the rest is calculator work. And for this problem, the radius is only slightly more than 1.01 or so centimeters. Here are the two problems that I would like for you to do for tomorrow's warm-up, and make sure that you're using that formula for r when you're doing the radius problem. Good luck. So yeah, do these two problems for the warm-up, and one more thing that I want to talk to you about. This is kind of a bonus to this video lesson. These are what are called composite solids, where they are made up of either the addition of two pieces or else maybe the subtraction. So here are kind of some strategies to use to solve these. This one, number 21, looks like it's a cylinder, but it's missing a hemisphere. So start out with the cylinder formula and then subtract 1/2 of a sphere's formula. This one looks like it's a cylinder plus a hemisphere. So find the cylinder volume and then add in 1/2 of a sphere's volume. This last one looks like it's a hemisphere plus a cone. So just kind of think of those strategies of what piece is it, add it or subtract it from whatever the other pieces are. Okay, good luck.